Okay, so let's start. Welcome everyone. Today we will have our third online workshop, and today the topic is building scroll with ZK-EVM. And before we start, I'd like to introduce a little bit about ScalingX. ScalingX is Web3 accelerator focused on the blockchain infrastructure, especially zero knowledge proof technology. And we manage 20 million USD to invest the best founders and teams. In addition, we aim to educate, promote blockchain infrastructure technology around the world. We empower early phase Web3 startup with talents and other startups. So today we are glad to invite the engineer from Scroll. And what is Scroll? Scroll, it is a native zk-EVM scaling solution for Ethereum. And the topic is building Scroll with zk-EVM. So let's invite Vincent from Scroll. Vincent, your turn.
Hey, everybody. My name is Vincent, and I'm glad to have this speech for ScalingX ZK Hackathon and to introduce Scroll's architecture for you guys. So let me just share my screen. I have a PPT provided for you. Can everyone view the screen?
Yeah. Yes.
Okay, cool. So before I started, let me briefly give you some introduction to myself and Scroll. So as Bob just mentioned, Scroll is a layer 2 project. Actually, we are ZK rollup solution for Ethereum. Our core is zk-EVM. zk-EVM is a opcode equivalent version of EVM empowered by zero knowledge. So we can prove many transactions and opcodes in the EVM and give them the security and scalability into the layer 1. So basically, you can see Ethereum always suffered by its low TPS and high gas fee when transactions goes a lot. I still remember like 1 year ago when I tried to deploy abstract wallet into Ethereum, I have to pay around about $200 as a gas fee. I think it's unacceptable. This case is unacceptable for both users and developers. Also for some projects, imagine for a normal user, you won't want to pay like $200 to just deploy the abstract wallet on the chain, right? So this is also referred as a issue like impossible triangle of blockchain. Is a blockchain cannot support scalability, decentralization, and security together. In order to solve this problem, Vitalik wrote an article to discuss two rollup solutions for Ethereum. One is optimistic, another one is ZK rollup. For optimistic rollup, you guys may heard there's already a project called Optimism. They launched their mainnet, I guess, from last year, and utilized the optimistic rollup to do the scale the Ethereum. And Scroll is a ZK rollup solution for the Ethereum. We build zk-EVM, make it acting exactly like the real EVM. Compared to other layer 2 projects, they may add in some extra layer like a compiler. They may using different language to approach the same effect. But Scroll, we developed this zk-EVM deeply from the very low level through the opcode equivalent. You can also think we are equivalent to EVMs through the bytecode level. So if you want to deploy a contract or anything on Scroll's layer 2, you won't feel any different compared to deployed on the real Ethereum, because both sides EVM is bytecode equivalent. And with this ZK power, we can have a high TPS on layer 2. We can have low gas fee, maybe I guess up to 1,000 lower, 1,000 lower than the real Ethereum. And we can give users and developers project a better experience with developing on the layer 2 compared to layer 1. So this is briefly about the Scroll. And I just want to introduce myself again. My name is Vincent Jin. You can also call me Chuhan. I work in Scroll as an infrastructure code developer right now. I also want to share my story about how I joined Scroll. I have my master degree of computer science, master degree of computer science at NYU at 2020. It was that time I started to notice that people are talking about zero knowledge part stuff, and as 2021, I noticed that Ethereum Foundation launched initialized open source project called ZK EVM. It's hosted by Ethereum Foundation PSE team, but you can notice that most of the contribution have done by a team called Scroll. It was that time I realized that Scroll has very good understanding on ZK, and they as a team is full of passion. They want to build this ZK EVM with to build it, make it as the best solution for ZK rollup. So I started to trying to contributing to this project too. After several successful commitments, founder of Scroll named Ye noticed me, and he asked me if I want to join Scroll as a full-time developer. And I said yes. Then the stories begin. So I think I share this stories because one, I want to emphasize that Scroll is basically the community-driven project, because we are born from an open source project initialized by Ethereum community. So we very valued every members in the community, and also this experience may be helpful for some audience who also want to have attain a position in Scroll. If you want to join Scroll or have like work or contributing to Scroll, I think the best practice is to start to contributing to our projects through community. Because I think the advantage of doing that is the community members will notice you, the Scroll team will notice you, and I think eventually you will get the desired reward after you contributing to the Scroll community. Okay, that's quite a lot for introduction. I'm also glad to have one of my other teammate here named Colin. If after my speech you have any question, you can ask both me and Colin. Now let's jump into our today's topic: building Scroll with ZK EVM. I guess many of you may know what is ZK EVM, but I think the entire architecture of Scroll may not be revealed to you as before. So today I want to give everyone Scroll's architecture, infrastructure architectures, and help you to better understanding how Scrolls can become a layer 2 solution for Ethereum. And today I choose this name because I want you to have another standpoint to view this question. Like, for example, assuming that you are the founders of Scroll. Now you have a ZK EVM, which is stable and reliable and can generate some proofs. How do you use this ZK EVM as core to build a layer 2 project? So ZK EVM is great, but what else we need to build a layer 2 project, to build a general layer 2 project? Have anyone has any idea? You can write down. You can type and post it on our meeting chat channel. Any guess? Any guess? Besides of the ZK EVM. Okay, then I think the first, from the very beginning, I think you need a hardware, right? You need a hardware to run ZK EVM, because to generate some ZK proofs, you have to consuming a lot of computing power. So you definitely need some machine like GPU machines and with good power supplies to be able to run ZK EVM. That's the beginning. That's the beginning stone. That's the beginning step. So we have a prover right now, which is running zk EVM to generate proofs. But what else we need also to make it become a layer 2 project? I already give you some hint through these arrows. This is also represented as a data string. One direction is input, another direction is output. Anyone have any like guess from the input? What else we want to support the prover? Think about it for like 10 seconds. Okay, I give you the answer. It is sequencer. So what is sequencer? It's just a name of some magic box or magic component connected to the prover. No. What sequencer doing is to order our input data to the zk EVM. Imagine if you are not building a layer 2 project, but for another simple zk project, you still need to have a zk circuit, right? But your zk circuits does not understand how to order the input. They only take the input and generate proofs. They don't care about the order. So the correct order is very important. In terms of zk EVM, our input should be the series of opcodes because we are opcode equivalent EVM. So what sequencer does is to order all the output opcodes through the right one and feed into the zk EVM running on the prover to generate the correct proof. So if you think about this way, if a sequencer doing is to order the opcode to the right way, what makes the best example or best practice to become a sequencer? The answer is Go Ethereum itself, right? We can run Go Ethereum, and Go Ethereum itself will order the transactions and make it into a block and generate outputs called trace. If you ever used Go Ethereum's debug RPC service, you can fetch trace from the Go Ethereum, and every trace will have detailed of opcodes and ordered for every transactions. So that's basically what we need. So sequencer in our case could we also think about the forked version of Go Ethereum. Here is some definition that we made for the sequencer. Serving as an extension of the gas fork, the sequencer provides additional functionality for orchestrating the creation of roll-up proofs. The sequencer is intended to launch only if it can connect to a scroll version of gas, and it is fundamental for many of its functionalities. So the last sentence, it means because we have the roadmap to decentralize sequencer. So if we want to decentralize it, when every individual nodes want to run the sequencer, it need to able to connect to scrolled version of gas, which means our entire network. Otherwise, it is not a available sequencer. So I think it's pretty easy to understand. But what I want to emphasize is the first sentence. The sequencer in scroll is just as an extension of the gas fork. Okay, now we have a sequencer to do the input work for our prover. What else we need for the output? Like you have a series of data input into zk EVM, and then zk EVM generate proofs. What we need to do with these proofs? I just want to remind you that we discussed the impossible triangle before: scalability, security, and decentralization. So if layer 2 can solved the scalability of Ethereum, how does it maintain the security? The answer is we maintain our security by utilize the power of Ethereum itself. So your proofs should be directly recorded on L1 contracts. L1 means Go Ethereum, Ethereum itself. So basically, you generate proofs and you submit your proofs onto Ethereum. Ethereum helps you to record it because Ethereum is validated many times to consider as it is safe. So your security is empowered by the Ethereum itself. So people don't have to worry about if layer 2 sometimes limits their security, right? Then there is the question, how to write a proof to Ethereum? The answer is we need a bridge. It's pretty obvious, right? A bridge to connect layer 2 and layer 1. But yeah, besides of just write the proofs to layer 1, bridge also supports connect layer 2 and layer 1 as a general definition of bridge. If you have previous heard about other bridge protocol, what it does is maybe they connect two different chains, they exchange data between different chains, right? So here, in Scrolls architecture, bridge also does the similar things. Besides of the just submitting proofs onto layer 1, bridge also help us do some assets transfer between layer 1 and layer 2, because just reminding in your mind, fundamentally, layer 1 and layer 2 are two different chains. So if you want to have some interaction between them, you have to have a bridge. So what bridge does, we can conclude as we will relay the deposit events on layer 1 to layer 2. We're going to relay the withdrawal events on layer 2 to layer 1. We're going to write proofs to layer 1. There's three fundamental functionality that bridge have to have for the users. For example, if you want to transfer your ETH to layer 2, you're going to initialize the deposit events on layer 1, and bridge will do some fantastic things, and finally it will release your message on the layer 2, and you say, and when you switch to the layer 2 network, boom, you say your address will have the balance that you want to transfer to the layer 2. And if you take a look at the fourth column, I put a question mark here. Besides of this three functionality, what else can bridge do? In fact, there's many extensions that bridge can do. For example, it can do some gas oracle things, try to pre-calculate some gas to give people more efficient way to relay message. It may also not only relay the deposit and withdrawal events, it may also relate entire contracts call, and maybe just record the entire contract state and relate to the relay between different layers. There's many possibility with bridge. So if you want to do your own ZK project, carefully to design your bridge is always a good choice. Okay, now I have introduced what is bridge and what is bridge doing. What else we need? Yeah, we have a lot of provers, right? We have a lot of provers right now, because only one prover looks like it's not enough, because ZK always consuming a lot of computing power, right? So we're definitely gonna have a lot of provers in our prover pools. Do we need to manage our provers? The answer is maybe we need, because eventually, if someone want to run provers by itself, you don't need a manager. You can always fetch a trace from the sequencer and use that data as input, put into prover and generate proofs, and directly call the L1 contracts and submit your proofs onto the layer 1. There's no need for a third party to manage the provers. But in fact, this will create some chaos, which means many provers will competing simultaneously for maybe one unproved block. But I think it's kind of like a wasting, right? So for now, Scroll provided a prover manager to managing different provers. We call it coordinators. It's not a must-have component, but we have. That's why I put maybe we need, but we have. Let me introduce what is coordinator to you. So what is coordinator exactly doing? First one, it distributes traces to provers. A trace refers to a block traces, which, as I mentioned before, is generated by the sequencer. It's a list of opcodes, right, as a data input into ZK EVM. So through this way, provers can gain more efficiency in getting their proving tags, right? They don't have to competing in the same block or same trace for many times. Coordinator also pre-verify proofs. We know our L1 contract can verify the proofs, but we always want the proofs can be pre-verified, because if you because if your verification is failed on layer 1 contract, you have wasting your gas fee. In order to save those gas fee, the coordinator will help you to pre-verify your proofs. If it is invalid, you don't have to waste your gas. You don't have to waste your gas. A third functionality, coordinator can also help you fetch and maintain traces from sequencer. It will mark if these traces has been assigned to some provers, or it already be proved, it already be recorded. All of this is designed to best utilize the prover's power. There's also a question mark here. Like, coordinator can do more things, right? Not only these 3 functionalities. So for example, coordinators can aggregate proofs together. It is proven by the ZK algorithm that like 10 of the proofs can be aggregated into one proofs, which means 10 blocks of proof can be aggregated into just one proof. And this one proof contains 10 blocks data, which means you only need to submit once, but it contains like 10 blocks data. Through this way, you can save in tons of gas fee, because writing on the Ethereum layer 1 always are gas consuming, because the gas fee is high recently. So coordinator can help a lot, but somebody also raised this question, like, eventually you don't need, now you have something like coordinator to manage provers. Does it like can be not very decentralization, not very decentralized, right? So we need decentralized it. Decentralized coordinator is not that hard. I mean, this entire design of coordinator can always be provided to the other party or the community. You can always build your own coordinator and have provers connect to yourself. If you have better design, better algorithm, I think you may win. You will become the winner in a coordinator competition. Like Scroll doesn't say like people can only use our coordinator to submit proofs. No. You don't have to. You can always submit proofs by yourself without a coordinator. So coordinator, like I said, maybe we need, but we have. Just want to give provers some better experience when trying to proving our block. So with all of those components together, now we have our Scroll architecture. So you as a founder, you can have a general idea how layer 2 project works right now. So we have a forked guess, which we call sequencer. It will collecting the transactions from the users, layer 2 users, and putting to generate trace. Trace will including execution logs, block header, transactions, contract bytecode, marker proofs, blah, blah, blah. And this trace will be redirect to the prover through coordinator. Sorry, there's like a part of coordinator, but don't worry. The prover will run in ZKEM circuits, which will generate proofs, and it will aggregate the proofs to a single proof, and through coordinator to put back to L1 contract, and bridge, through bridge, put back to L1 contract. And the coordinator will pre-verify the proof. And as an individual hosting prover, you can always directly deploy your proofs onto L1 contract without a bridge, because all the like submit APIs, it's open. Here is another picture to view about Scroll's architecture through the network way. This way give you more detailed view about it. So we have a layer 2 POA network, which is sequencer. Now the sequencer is centralized, so it's the consensus algorithm is POA, proof of authentication network, and we have bridge to redirect withdraw events to the layer 1. It will also watch a layer 1 deposit events and redirect to the layer 2. You see, we have a coordinator here. I have coordinator to manage different rollers, which is another name of provers. You can see these are same things. So this is the more detailed network architecture for Scroll. This is a pre-alpha version, but it's not. We do not change a lot compared to the alpha. So this graph can also give you some idea about how the architecture looks like. Cool. Now I finished the introduction to the Scroll's architecture. For users and developers, if you use Scroll, the experience is basically just as you are using Ethereum itself. I can say have no some difference. So making your developing experience extremely boring. Just if you already developed some project, someone is requesting remote control of your screen. What does that mean? Can I just
ignore? Just ignore. Yeah.
Okay, can I decline it? Oh, okay, I decline it. Okay. Well, it's continuing asking me that. Can I click approve? I have no idea what.
I don't think so. Yeah, you can just continue your sharing. Yeah, no one asking for the remote control.
It's Zoom. It's Zoom itself. I have no idea what it is. Okay. I hope the screen is still there, right? Everybody can view the screen.
Yes.
Okay, cool. So currently Scroll is at phase 3 alpha testnet. We just launched our alpha testnet at a few months ago, and it's already on Gurley. Our team is working on the road to launch the mainnet. We estimate we can launch it through Q3, just like our co-founders declared during the Hong Kong Web3 festivals. By the way, I was there also. After we launch our mainnet, we're gonna decentralize our prover network. Like I said, it's very easy to do that because eventually the prover network is already open for everybody. It's already open for everybody, and everybody can have their own coordinators. Everybody can submit proofs by themselves. It's just now we do not open this open this to the community. But after we launch mainnet, we can easily open it and have everyone join the proven network. After the decentralized proven network, we're gonna decentralize our sequencers. It's also not a very hard job, because you can see our sequencer is already a forked guess. So it's just because the consensus is POA. If we change our consensus to another decentralized algorithm of consensus, it will easily become a decentralized sequencer. To launch the mainnet, we still have something need to be done, like complete the ZKEVM circuit. There's some uncommon errors and pre-compiled contracts, to-do list to do. We still need to finish our auditing, especially ZKEVM circuit auditing. You know, currently there's not many like entities have the technology, have the enough skills to auditing ZKEVM. So we have to deal it carefully, because the security is the best concern. We also need to do some optimizations for our entire architecture, entire ZKEVM. For example, we also need to do some acceleration design, both through ZKEVM circuit and hardware. But right now we have pretty good data on our alpha testnet. We have 3.1 million unique wallet address deployed on our alpha testnet. We have 15 million total transactions. We have 582K contracts deployed on it. It's pretty good data right now. Since Scroll's alpha testnet, we have 150 Hackathon project deployed on Scroll, 100 from ETH Denver, another 60 is from ETH Beijing, and we have 60 plus deployed ecosystem projects, which is good, contain some big name like Uniswap, AAVE, and Hub Protocol, which is bridge protocol. I think you can check the details about our ecosystem project on our website. Here is some ecosystem projects logo. And if you have your own project, if you are a startup, if you have your team and you want to join Scroll's ecosystem, we provide a type form for you to fill out, because we're going to launch a ecosystem plan called Build with Scroll. And you are like I said, Scroll will value our community. If you join our ecosystem, join our community, the Build with Scroll, this plan will give you many supports to help you grow. So don't hesitate to submit your applications through this form. And we will also attend many events this year. You can find our Scroll team in the list of these events hosted this year. Okay, this is some general information about us, our testnet, our Discord. If you want to join the community, please scan the QR code to join our community as soon as possible. And also, if you want to acquire a job in Scroll, here is also a hiring QR code for you to scan. But like I said before, from my experience, contributing to the Scroll's community may be the best practice to start your step your foot into the Scroll's team. Okay, thank you. That's all. That is all of today's speaking. And I noticed there's a questions on meeting chat. Let me check it. Hi, Chuhan. Let's talk about ZKEVM. I have two questions. What's the max TPS that Scroll ZKEVM can support? How long it would take to generate proof? How many GPU used to generate proof? Okay, so the first question, the max TPS from theory limit, I think it's up to 2000 TPS on Scroll's ZKEVM, which is a lot because it's involved with like transaction costs. You cannot compare to the other simple ZK circuits, because those are designed for some simple interaction, but ZK EVM is designed for the full interaction, full opcodes. So it's around 2,000, but I think it's quite a lot on theory, in theory terms. And how long it would take to generate proof? I think right now, from our observation, we can generate the proofs under 20 minutes. In the best case, under 20 minutes. But that require you have a very good GPU machines, but on our testnet, it may take hours because we do not have enough provers right now. We still try to acquire more provers into our alpha testnet. How many GPU used to generate proof? That's a good question. I think we don't need many GPU to do that. The only thing we're consuming a lot is memory space, like I think, how do you call it, like memory, right? Because I forgot the exact English name for that on the GPU machine. And also we need a very good CPU to support it. I think the lowest GPU requirement is 64 threads. Does anyone have any more questions or any concerns? I was hoping you guys enjoying this speech. I'm not sure if I make every slides clear, because I got cold and my throat feel like paining right now. It's like burning. Okay, there's no more question. I'm gonna stop this share.
Hi, thank you for the sharing today. And here's the POAP for everyone to mint. We'll have a few minutes, so you guys can literally scan the QR code and you'll get your POAP. And thank you everyone for attending our workshop today. Thank you.
Okay, yeah, we can leave if you join today's session, you can mint the POAP. And also, if you are interested in our Hackathon, you can click the link to join our Hackathon to submit your project. Okay, I think that's all for today's sharing. Yeah, thanks again. Thanks, Vincent, and thank you, Scroll team. And yeah, that's all.